I've made some more coils and comparator boards. Unlike the original board, I haven't attached all the components around the outside of the board because that was kind of messy. So instead I've attached wires, which are not messy at all. There are two different sorts of comparator chips I've used. This is the 393 that I was using before, the LM393, which is a dual comparator, and these ones are LM339s, which are quad comparators in a 14-pin package, and I've got 7 coils all wired up and ready to go. So I've made another bodge board. This one is basically, if I bring up the circuit diagram, these are all the feedback resistors for the comparator circuit, only I've replaced them with variable resistors, or potentiometers if you prefer, so that I can play around with the values in and about the region of the reference diagram. The only one I haven't changed is the actual feedback resistor, which is a 20 meg resistor, and I don't have anything even approaching a 20 meg variable resistor. In addition, I'm going to be sticking a wire through the coils and reading the and ascertaining what sort of waveform pattern we get out of that, and I need a load for that, which is going to be that wavy there, and that's only a 500 ohm potentiometer. I think 500 ohm would be plenty for the maximum. So the next step is I'm going to run a wire through all these coils, and then I'm going to connect it to the load resistor at the one end, and then the other end of that load resistor will go down to ground. For each comparator, I'm going to connect it up to feedback resistors and one of the coils, and then I'm going to get it up on the scope and have a look and see what difference tweaking these values does to the output. And I'm going to do it for all 7 coils, all 7 of the 8 comparators on the watch boards, and see if there's any difference. Exciting, isn't it? The rat's nest is now ready for testing. What do we have? Each coil is connected to the comparators directly. The outputs at the moment are, that's not an output. The outputs at the moment are not connected to anything, but then the comparators are not connected to the watch board either. That's what these wires here are for, and I will sequentially connect up those wires to each comparator and coil and see what the output is, and maybe twiddle the pots. All the power goes back to here. All the wires going off the screen at the top will be going to either power or the signal generator or the oscilloscope, and that's just to keep them out of the way. I've set these potentiometers values to be the same as they are in the application notes for the LM393. The blue wires here, one goes to this potentiometer here, and the other one goes through all the coils and pops out at the top. That's where the signal generator is going to be connected. At the moment, this potentiometer is set to 50 ohms, which is the output impedance of the signal generator. So hopefully that will be the right value for it to be. But again, we can twiddle it and see what happens. The blue wires here are an isolated circuit that just has a signal going through it from the signal generator, which you can see on the yellow. The output is is the blue, and that's coming through this wire here, this green wire here. This is the output, and at the moment it's just going through one comparator on this board over here, and we've got these 3 pots here that we can adjust to see what happens. Now I am conscious of the fact that I don't want to dump too much current through the comparator's inputs, because that would be bad. Essentially these two control the comparator's inputs, or the resistors on the comparator's inputs, so the pull up and pull down resistors. So I'm not going to tweak them too much, because connecting them to the rails is probably a bad idea. This one here is essentially the load current for the output. Now I'm not quite sure how I'm going to end up using that, to be honest, whether I'm going to use that to drive an inverter or whether I'm going to drive an LED directly from it. I don't know yet, but we can adjust that and see if that has any effect on the output signal. I wouldn't expect it to have too much effect on the input signal. But let's see what these do first. So I'm just going to tweak them a little bit. Well, that made absolutely no difference whatsoever. In other words, I don't really need to change these to optimize them for any purpose whatsoever. So 10 kilo ohm resistors for both of those positions is fine. So the other one is the output. I wonder if that does anything useful. Again, I'm not going to tweak it too hard because I don't want to break anything. Oops. Well, I immediately touched the rail with that, which was a bad idea, which is why it went flat. There's a little, this is turning up the resistance. So that's at 20 kilohertz now. It adjusts the signal a little bit, in that it makes it a little bit rounder. So that one's nominally set for 3K. This one here is the load on the signal generator, which is set to 50 ohms, I believe, which is the output impedance of the signal generator. If I change this, I wonder if the signal will go weird. Well, there you go. It definitely has an effect on the signal generator input, although it doesn't necessarily have an effect on the output. Out of curiosity now, what I'm going to do is I'm going to disconnect the output signal here on the green wire, so that will disappear. And what I'm going to do is I'm going to have a look at the input signal on the coil. So that's the signal we're getting on the one side of the coil, and that's the signal we're getting on the other side of the coil. There's a bit of DC offset on that, and that DC offset is what's being generated by these two potentiometers, resistors. So what we have now is we have the blue channel connected to the one side of the coil, about here. The yellow channel is still connected to the signal generator, and the red channel is the output. So we've still got the output. We've already decided that there's quite a bit of DC offset on the input, and if we adjust the... Does that go up and down? Yes, it does. So if I increase the resistance on the potentiometer that's connected to the ground rail, then we adjust the DC offset on the input coil, at least on the one side. Should we see if we can do that on the other side as well? So what I'm doing here is I'm adjusting the bias resistors on both the positive and negative inputs to the comparator to see what effect that has on the signal. And essentially all we're doing is we're changing the DC offset and maybe making the signal a little bit flatter. As a consequence, I think I've basically decided at this point that the 10k values in the application notes are perfectly fine for these resistors, and that I don't actually need to make any changes to them, or that any changes would actually help the output signals. So from this point onwards, I've decided I'm not going to test each individual comparator. So the other thing I want to try now is removing the signal generator signal going through the coils, just to make sure that my output becomes flat, so I don't get a signal output. So that's the red line. So I'm going to lose the blue line. Oh no, we're not. Okay. So if I disconnect the blue wire from the signal, oops. So what I've done now is I've grounded the signal going through these coils, and that gives me a flat output, which is kind of what I want. And you can also see that I've got a flat input as well. So the coils are doing what we want them to do, and the comparators are doing what we want them to do. At least these comparators are. So the next test to make, now we've got the signal back up and running again, is to change the frequency of the input signal and possibly the waveform to see what it does to the comparator output. At the moment we're running it at 10 kilohertz, which looks about right for the scope. So that's at 0 hertz, and you can see that we're just picking up noise, so that's obviously not going to be any good. So that's interesting. This is at a 1 kilohertz, so if I drop that down to a millisecond, is that going to go the right way? We get quite a noisy output at 1 kilohertz, which is interesting, and it's on the falling edge. I'm going to slowly wind up the frequency, so that's at 2 kilohertz, and we can see that we get less of a weirdy edge, and at 3 kilohertz it's not too bad at all. So this is 5 kilohertz, and that looks pretty reasonable to me. Interesting that there's such noise, isn't there? I do wonder whether or not a capacitor would fix that. Oh, that's an interesting effect that the capacitor has. It does increase the amplitude of the input signal. Or is it me, because I'm connecting myself to it? I think that's me connecting myself to it. So the capacitor doesn't seem to do a great deal of anything. That's fine. I wasn't planning to put capacitors on anyway. And I seem to have lost that one. Okay, so we're talking about 5 kilohertz as a reasonable signal. So what I'm going to do now is I'm going to try and change the type of signal. So, so that's a square wave signal, which probably would benefit from a capacitor. Let's try a capacitor on that one. No, not really. The output's awful. As you can see, I wouldn't be happy with that at all. So we're not going to be doing a square wave input. Right. So a triangular wave again produces an okay output from what I can see. So what I'm looking for the signal generator ultimately is either a sine wave or a triangular wave output, rather than a square wave output. So if I were to generate a signal to go through the coils, that signal needs to be not a square wave, basically. The next section will be to build out the bodge board with all the right resistors for all 8 of these coils. The number of wires has multiplied a little bit, but what we've done essentially is we've now disconnected our adjustable resistors here for the biasing and feedback resistors. We've replaced them with fixed resistors, so there's biasing resistors for the negative input, biasing resistors for the positive input, and these are the pull-up resistors for the outputs. And these ones here across the middle, these are the feedback resistors going between the output and the negative input, so that's the negative feedback. And all these wires then go into a bunch of terminal blocks, which then go back to the little circuit boards here, which you can barely see now, and here, which contain the comparators, and then over here we have the coils. Now I've added an extra couple of wires through the coils, so the first wire, which will be the first one we try, goes through all the coils, and that will enable me to test whether or not I have an output on each of the outputs, which I should have at that point. Then there are two more wires. One goes through all of the odd numbered coils, so the first coil, the third coil, the fifth coil and the seventh coil, and the other one goes through the even coils, so the second coil, the fourth coil, the sixth coil and the eighth coil. And what we should get on the oscilloscope is outputs on the ones that have the wire going through and no outputs on the ones that don't have the wire going through. So I've got my input signal and I've got a floating wire connected to the other channel on the scope, and I'm just going to go down and look at the outputs on all of these comparators.
So comparator number 1, yep, that's working. Comparator number 2, yep, that's working. Comparator number 3, yay. Number 4, yep. Number 5, yep. Number 6, yep. Number 7, yep.
Number 8. Oh. So I obviously have a connection problem here. I don't know. In any case, I'll have a look at that in a minute. So the next thing I'm going to do is the output was driven by a cable going through all of these coils, and what I'm going to do now is I'm going to switch to a cable that goes through alternate coils, and then we can see whether we're getting an output regardless of whether or not there's a cable going through the middle or not. And this one's going through the even coils, so I'm not expecting one on the end one because obviously that one's not working at the moment, but I am expecting one on 2. So if I go to the output for 1, I get very little to nothing. If I go for 2, I get a signal. If I go for 3, it should be nothing, and it is. And if I go for 4, we get a signal. 5 should be nothing. Oh, is that 5? Okay, I'm getting a signal on 5, so that's 1, 2, 3, 4. Oh, I passed it through the wrong cable, possibly. So I'm getting one from 5. I'm not getting one on 6. I am getting one on 7. And I'm obviously not going to get one on 8 because that's not working. So I've managed to confuse myself here somewhere. Let me double check my wiring. Okay. So I've messed up the wiring somewhere online, haven't I? I bet I've reversed the connections. Let me try the other cable. So I should be getting one on 1 with this selection, and I am. I shouldn't be getting one on 2, and I'm not. I should be getting one on 3, which I am. I should not be getting one on 4, and I'm not. I should be getting one on here. Can't remember. Oh, getting noise on that one. And the next one, I'm getting a noisy output, which is incorrect. It's the wrong way round. So this one won't be connected. A little bit of noise, but that's okay. And this one's obviously not going to work because it's not working. Okay. So I'm a little baffled at the moment, and it's obviously going to be a wiring issue. But I'm not quite sure how it's a wiring issue. I shouldn't get a signal on this one through this wire because it's not going through that coil. Does that even make sense? How do I get an in output on this one when this wire is not going through? I must have some wires mixed up, you know. I should get one on this one, and I'm not. So I think I've sussed the confusion, or how I've managed to confuse myself at least. If I pull up the LM339 schematic, you can see here that pin 4 and pin 5 are in 1 and pin 2 is out 1. Now I've looked at that diagram and I've seen, oh, pin 1, that's out 1. And we can see this because if I took on this wire, we can see that that comes down to here, pin 1. Can we see that on the diagram? Yeah, just there, pin 1. And if I tug on the yellow wire, it's going over to here to that pin there, which is pin 6. It shouldn't be pin 6 though. No, it's pin 5. Yeah, pin 5. Yeah, which is the opposite comparator on this side. So I'm just going to swap around these two green wires and hopefully they'll start working again. Why this one isn't working I don't know yet, but we'll, or why that one isn't working in fact. Now if I put a pin on that one, I shouldn't get a signal there, and I'm not, and I should be getting a signal there, and I am. So I should not be getting a signal here, which I am, and I shouldn't be getting a signal here, which I'm not. Right, okay, so these ones are the wrong way around as well. So in 3 is the bottom 2, which is what I'd want, and out 3 would be the top one of the blue wires. Which it isn't. Okay. So I've been completely idiotic in my wiring. Right then, do we get a signal on this one? Do we bugger? Do we get a signal on this one? Do we bugger? I don't know why that's not working. So as you could probably guess, the problem was the soldering. In fact, the soldering on this bodge board on the back. There was a couple of connections that weren't actually connected properly. So we should be getting a signal on all of the even coils, but not on the odd coils, because the wire we've got connected at the moment goes through the even coils but bypasses the odd coils. So number 1, just some noise. Number 2, nice square signal. Number 3, Just some noise. Number 4, if I can get it in. Nice square signal. Number 5. Just a bit of noise. Number 6. Nice square signal. Nothing on 7. Absolutely nothing on 7. Is that even working? And on number 8, nice square signal. So what that's sort of demonstrating, as it were, is that by choosing which of these coils, these 8 bits if you like, the cable goes through, we can select different output patterns from the 8 comparators. Essentially what we can do is, by having a bundle of cables going through the coils in different patterns, we can select a wire and then get a different 8-bit pattern out of the comparators. This is something that's called rope core memory. I'd like to say I thought of it, but I didn't. It's been around for a long time. In any case, I'm going to combine this rat's nest with the last rat's nest I made and sequence through 16 different connections, 16 different wires through here to make 16 different patterns on these coils. Will that be interesting?